Hello, this is how to use Microsoft Spy++. This application is part of Microsoft Visual Studio. I have installed Microsoft Visual Studio, the latest version, 2026, and I have selected the desktop development with C++. Let's see everything from the start. Inside the Visual Studio installer, let's look at the components that I have installed as part of Visual Studio. So I have installed the gratis version Microsoft Visual Studio Community 2026. And in workloads, I have enabled desktop development with C++. In order to start the application Spy++, first you start Visual Studio. And then from the Tools menu in Visual Studio, there's this entry Spy++. This application requires elevation as administrator. It will do more low-level things. It will inject in the process that we're inspecting using a hook. So this application is used for inspecting the contents of Windows. Windows in the sense of the basic building block of the graphical user interface in the Windows operating system. So in the sense that a button is a window, a label is a window, a edit box is a window. So most graphical user interface controls, at least the ones that use the native Win32 API, will use Windows. And for those windows, you can do actions such as sending messages. Those windows participate in the message dispatching in the main loop of messaging in the Windows graphical user interface. There are exceptions, the so-called aliens. You might have buttons that are not native Win32 Windows. We will see those immediately. So let's start with a very classic application that was written in maybe a number of years ago and used Win32 API. Let's see what we have available out of the box in Windows 11 Pro. So this doesn't resemble the Microsoft Calculator calc.exe that existed in the previous versions of Windows. I'm not sure if this is just a skin on top of the older calc application or if it's a total rewrite using newer graphical user interface toolkit technologies from Microsoft, such as, I know, Metro, Modern, Win UI. But we can inspect. So using the Microsoft Spy++ application, usually the first step that you do is click on the main toolbar on the Find Window Alt F3 button. In here we have this cross icon, and with this we're going to select, for instance, the button 0. Then press the OK button. Says that there's nothing to find. Let's refresh, F5, and search again. And now it could find it. So this is a list of the windows that are available in the Windows operating system. So Windows are multiple things to Microsoft Windows. Microsoft Windows is an operating system, but I am using a local Windows user account, which is called admin, and I'm logged into the graphical user interface session. So inside here, I'm logged in This is the graphical user interface shell. This is the process explorer. This panel is part of, well, used to be part of the Explorer process. The desktop used to be part of the Explorer process, and also the start menu. There's a hierarchy of processes, and then the graphical user interface objects, again, the controls, but also the individual window. So this is a window with a window decoration, a window title bar, the buttons in the title bar, minimize, restore, maximize, and close. The icon, the title bar menu, which you can get to by clicking on the up icon, or if you right click on the Windows title bar. Okay, so this is a window, the entire rectangle that moves right now, but also this is a window, and this button is a window, and this button is a window, this button is a window, this button refresh F5 in the main toolbar is also a window. Again, the window is an atom in GUI controls hierarchy in Windows, and it's just that, it's a actual hierarchy. There's parents and then there's children. This is MDI format, so this is multiple document Windows, which works like this. If you maximize a window that's enveloped in another window, it will show up, it will have its minimize, restore, close buttons in the main menu of the application. So this window is the hierarchy of windows, of atoms, and all of the processes and windows that you see right now are present in this tree if you press the refresh F5 button. So this list of atoms is not, this tree view of atoms is not refreshed automatically. You need to remember to refresh it from time to time. Okay, right now we have this tree view of atoms. It contains at least a window for the calculator application. But previously, when the calc application was a Win32 app, there used to be individual windows for all of the buttons that you see in here. Okay, so I'm trying to do the exact same thing, which is using SPY++ to see if there's a button, a atom, a window corresponding to the button 0. And there's no such thing. This atom represents the entire window that I move right now, which is from the process calculator, the main window that has an icon in the main panel in the taskbar, and that participates in Alt Tab. And then underneath it, there's the application frame input sync window, which is probably the most part of what you see in here. And there are three other atoms. One is there's two title bar windows, and there's a calculator core window. I'm not sure exactly how to show which is the rectangle of this window, or of this window, or of this window. Okay, so this is a fairly modern app that's that doesn't use that many Windows atoms. So it's alien style in the sense that this button can be interacted with via mouse, via automation, via a screen reader, probably also with the keyboard keys. So let's press on the 0 on my keyboard key, on 1. So when I press the keyboard key 1, the button 1 is being pressed. Okay, so the button does exist. You can interact with it, but it's not a Win32 Atom window. This is what I call when I say aliens. The button is there, not accessible through the tree view of Windows. You cannot probably send it Win32 messages using the main message loop message pump in Windows with send message and post message. Okay, so this is a fairly modern app. Let's find an application that's not that modern. I didn't find many, maybe none of the applications inside the Windows Start menu seem to use the older UI. But I went to the directory c:\windows\system32. I have sorted by the extension. I'm looking just at files with extension .exe, and in here I could find a number of older applications which use just native Win32 UI, nothing else on top. For instance, WinVer. So there's an executable in Windows called winver.exe that shows in graphical user interface mode the version of Windows. There's an alternative for the command line that's called just ver.exe. So let's see if WinVer is such an application that doesn't use aliens, doesn't use Metro, WinUI, Modern, etc., and other toolkits from Microsoft, doesn't do custom painting, is not a web browser. So just refresh in Microsoft Spy++ main toolbar, refresh button F5. And then we're going to search, and we want to go straight to one of the labels in here, in the WinVer application. And this is what I could see previously in other basic Windows applications that are built into the Windows operating system in the previous versions. So when I move with this crosshairs tool over the individual atoms, I can see the rectangle of the atom. So this button does have a rectangle, this label has a rectangle, this label has a rectangle, this is a multi-line label with this rectangle. The rectangles are also not expected. So I would expect all of these rectangles to have the same right coordinate and have the same width, but they don't. Maybe it's an issue, maybe not. Maybe just this is the way labels wrap. What is not inspectable here is, or maybe I'm looking wrong at the thing, is this graphic, this image. So maybe a theory is that this is a window, and on top of the window, using custom painting, is painted this, I don't know, maybe PNG image with the logo of Windows and says Windows 11. But then everything else, all of the other controls, are actual atoms, including this separator line. Okay, why didn't it expand the tree? Maybe I don't know how to select these separator horizontal line. Let me select the label with this hyperlink. Okay, and we can see some important things. We can see that these labels are classic labels, don't have anything special in there, they're just text and font. Whereas the label that I have selected is special because it contains text font plus a hyperlink. And we can immediately see what the hyperlink looks like. It's less than A, and then Microsoft Software License Terms, less than, and then slash A, and then greater than. So it's an HTML snippet that's incomplete in the sense that it doesn't contain the href, because this thing actually will open a web browser. Not, it opens a native window, but it has the text of the HTML anchor. So how this works, probably there's an event with on-click on the syslink, and that's intercepted, implemented in this application, and then it's going to show this other window. Let's see how this other window behaves. So there's a RTF control. So there's a top level window named Microsoft Software License Terms. This window is modal on top of the About Windows window. Why do we know it's modal? Because you cannot do anything inside the About window. You cannot click on this link, you cannot click on the OK button, you cannot close the application, the title bar context menu doesn't appear. But both of these two windows, this one and this one, these two atoms, are on the same level in the tree view of atoms. So this is not a child of this atom. Okay, so let's inspect this very simple window. It has an OK button, which is an atom. It has an RTF control, which is an atom. And then the entire window is an atom. The window has title bar, caption, so window title, close button. If you have an atom that's actual a window, you can specify that the window should not be resizable, that the window should not have the minimize close button, minimize restore button, just the close button. You can specify that the window should be a tool window style, have different title bar because it's a tool window, etc. Okay, the rich text format RTF control. How do we know it's an RTF control? Because we can guess it is. There's bullet points, there's various fonts, there's bold, there's this justification, left alignment. So says class rich edit 50W. If I remember correctly, there's an entire DLL that's providing this control, something which rich ed, where is it? Rich ed and then the version, or rich edit edit. Yeah, probably this guy, reach add 32.dll from c:\windows system32, which is a 64-bit DLL. And this is hopefully a 64-bit process, the WinVer. Okay, so what else we know? We know there's a rich text RTF control. We know its internal name, rich add 50W. We kind of guessed that it comes from this DLL. We know its content. So this window caption. Let's copy the text, but we can't. So this is totally not RTF text. It's probably the start part of the RTF converted to plain text. Okay, what else do we know about this window? We know its coordinates, which is probably client rect or rectangle. We know its height width. We know its left and top. There's a very important identifier in the Windows graphical user interface system, which is called the Windows handle. There's a limited amount of Windows handles, or used to be in the Windows operating system, so you couldn't start many applications that have thousands of buttons in it. Okay, the window handle acts as a pointer in C and C++. It is used to uniquely identify a atom and also to communicate with that atom. So another process can change, for instance, the content of the RTF by using a standard Win32 API function, I know, probably send message, destinated to this window handle with a message type, I know, set RTF content and then the new RTF content. If the other process has enough permissions to access this control inside this window. Depending on the type of the atom of the Windows control, you will have different available styles and extended styles. And then there's a hierarchy of atoms. Each window, each atom has a parent, which you can see in here. Says parent window is Microsoft Software License Terms with this handle. You can click on the handle to navigate to its parent. So we're going to navigate to this atom, the entire window. I'm not sure what happened there. It says that the caption is about Windows, so it navigated to this other window. Okay, and then there's internal details about Win32 API, about the control. There's a class style, a class name, window procedure, the cursor, so the icon that the mouse should show if you hover on top, on the window. So we're not in the RTF window, we're on the entire window. Let's go back to the RTF window. In here, there's no defined cursor handle, but it's the I-beam text select cursor. And on top of the selection, there's the normal cursor, the arrow one. So if you're programming using the Win32 API, you will get to encounter and to know if you're programming in low-level mode, in the sense that if you're programming straight using Win32 API, nothing else. If you're programming, for instance, using C++ or Visual Studio C++ or MFC, ATL, etc., or raw C programming language usage of the Win32 API, you will get to encounter all of these properties, values, types, enums, etc. And methods, procedures, functions. But usually you're not going so low level. Usually you're using a more higher level toolkit. Maybe you're using the Qt framework. Maybe you're using C# System Windows Forms. Maybe you're using C# XAML System.Windows, or any number of other graphical user interface toolkits, which might use just aliens, nothing else. Or graphical user interface toolkits that are just HTML contained inside a Windows application. For instance, an Electron app. Okay. So if I right click on a atom in the atom tree, I go right click and highlight, it will show the rectangle of the window. It will highlight it a number of times. Let's restore the MDI Windows, and from the main menu of SPI++, from the SPI submenu, we'll select processes. In here, we'll select the application, so WinVer. And under the WinVer process, we can see its threads. It says that there are 3 threads, and all of the atoms are part of the first thread, this many zeros ECO WinVer. As far as I know, there's a main thread in Windows processes, which is the actually thread with ID 1, the first thread. And only this thread is allowed to do graphical user interface main loop actions. So sending messages, receiving messages, painting, etc. We can see that even this horizontal separator line is actually a label with the empty string as text. These two are special. This one doesn't have a highlight menu item. So this is the horizontal bar, but this one doesn't have a highlight option if you right click on it. I'm not sure if this does respect the tab order. So when you have multiple atoms on a window, on a page, you can navigate from one atom to the other using the tab key, or backwards using the shift tab key combination on your keyboard. There's a tab order for each of the graphical user interface controls that can receive focus. Labels cannot receive focus, but probably these, I don't know, let's actually test. The anchor part of the label can receive focus because otherwise you cannot action it with just the keyboard. So if you don't have a mouse or any other pointing device, you can use your keyboard key tab to navigate through all of the controls that have actions. For instance, you navigate to the anchor Microsoft Software License Terms by pressing the tab key once, and then you can press the space key, the space bar, to perform the action that would happen if you click on that hyperlink. You can exit from here either using escape if there's to that window an escape action, and that's probably either closing the window or pressing the OK button. You can also exit because currently the highlighted selected control Win32 atom is the OK button, so you can press on it by pressing the space bar or pressing the enter key. Or you can close this because it's a window, it responds to the this shortcut, so Alt F4 to close. Maybe some of these are not displayed or have zero width, zero height, or they're used for communication. And the icon is different for these atoms. It looks like disabled. I'm not sure why this icon is shown, but one of these properties makes this label special. I'm saying label because I can see static in the information about this atom. And labels tend to be static. Maybe statics can be used for other things than labels. This is not a static. It is a label, but is a more special one. Is a syslink type. Has a bounding rectangle. Process ID, thread ID. So atoms are part of a Windows process with this process ID, which is probably hexadecimal. And then they're also part of a thread, which is again just the main thread of the process, the one that does graphical user interface actions. I'm not sure how messages works. I don't know how to make it work correctly. I would expect if I'm seeing the messages that are being sent towards this control or received by this control, to be able to see on mouse hover, on mouse enter, on mouse exit, mouse double click, mouse click, pressing the spacebar key, etc. But I don't know how to actually log those messages. And I hopefully Spy++ can also send messages to these atoms. There's an enum of messages that can be sent to, standard messages that can be sent to atoms. There's a double click message, a close message, a change the text message, etc. This IME and another IME sounds like input messaging techno engine, so it's probably for input method. So for an input method engine for assistive technologies or for writing non-Latin characters such as Chinese traditional characters, etc. Let's see another application that doesn't use aliens, regedit, registry editor. There's also this executable c:\windows /system32 regedit 32. Let's open an editor dialog, so edit string. You can change the value of the data of a value. Oof. So no aliens here. There's labels, probably edit box read only, label, edit box read write, and then two buttons. You can see by the class in the Windows window. So here it says class. You can see button, button, dialog, edit, static, edit, and static. Let's refresh the list and go to this read-only thing. Okay, so it says common files x60, x86 edit. So it's an edit box. It's visible, but why it needs to be an edit box? Because you want to be able to select this text for copy-paste purposes. Why you cannot change the value name? Because there's this action where you double click on the, where is it? Where you right click and then rename, and that edits the value name. If you want to edit the value data, you double click on it, or right click and modify, which is the first action and the bold one. And in here, you're allowed to just change the data, not the name of the value. I have opened another window, which means that these atoms are all invalid don't exist any longer. There's a parent window which is the edit string. Again, you can navigate to the parent. This edit box is marked as having a previous window, which is its own edit box, its own label with a value name colon content. And also important, you can see the accelerator. So this ampersand character means that there's an accelerator beneath the N letter. Let's see the similar thing for the second edit box. Okay, so the second edit box, right click on it, properties, and the window, and previous window says value data, and the accelerator is the uppercase V. So let's see how we can get there. Press the left Alt key, will show the accelerator, otherwise you cannot see accelerators. So right click on the registry value, modify, and now you cannot see the two accelerators, so there's an accelerator underneath this lowercase n for the value name, and another one under this uppercase V under value data. In order to see the accelerators, you press the left Alt key once. If you press it multiple times, the accelerators will not be hidden. And now you can see that if you press Alt V, the focus will be shifted to the control value data, which is a label. So Alt V. And this label cannot receive focus because it's a label. So the focus will navigate to the next control in order. I'm not sure in which order because there's no tab order. The labels don't participate in the tab order. So probably either the label is related with the edit box. So there's somewhere inside the label a property that says that there's an edit box corresponding to this label. Or there's another list of atoms that's not the tab order that specify that the next window after this label is this edit box. Okay, so that's in broad lines what you would use SPI++ for to determine if the graphical user interface control that you want to debug, maybe it's not being shown, maybe it's being truncated, maybe the rectangle is not perfect, you can't see the entire text inside the control, maybe it has the wrong color, the wrong background color. So the very first thing that you would do, you would run that application that has a graphical user interface glitch, and then using SPI++, you would press the refresh button and navigate using the crosshairs tool towards that control and try to inspect in there and see. Maybe you're very lucky and that control is actually an atom. There's no aliens in that place. And in that case, then there's a multitude of things that you could do. You could, using either SPI++ or another tool, you could, for instance, change the rectangle of the of the control of the atom. You can change the height, the width, until you make all of the text inside that control visible, not clipped, not truncated. Or maybe you want to see how changing the color scheme would look like. Maybe you want to change the foreground color of the text, the background color of the text. That also can be done from the exterior of the actual running application. Or maybe you want to change the style of the font. You want to make it italic, bold, etc. Or, I know, maybe a atom, a GUI control is overlapping another one and you want to bring another one to the front, which again you can do use if they're not aliens, if they're actual Win32 window atoms. You can send a window to foreground or background by sending it messages. You can see if an atom is not responsive. That's because the main thread of the process is being busy, is not dispatching messages through the GUI main thread. Okay, so this is a special control that's called syslistView32. There's native built-in graphical user interface controls in Windows, the ones that you saw before, which are pretty basic. There's label, there's button, there's edit box. There are really complicated ones, like the rich text edit one, rich text format one, which actually is defined in a different DLL inside the Windows operating system. But then there's other more advanced controls. There's window main menus. There's maybe 3 or 4 different types of toolbars and main toolbars. There are list views, icon views, tree views. Some of these controls you can see if you install a integrated development environment, for instance, the Delphi IDE or Visual Studio C# System Windows Forms. And in there, some of the GUI controls that you can see in the palette in the Forms editor, some are just native Win32 API controls, some are existing on the system ActiveX controls. Some might be first-party controls from Microsoft Windows, others might be third-party, for instance, ActiveX controls if you have, for instance, installed the Adobe Reader PDF app. You also have installed on your system the Adobe Reader PDF graphical user interface control ActiveX. So in this case, it's one of the list views. And for the tree view, it's also one of the built-in tree views in the Windows operating system, systree-view32. And the other one is syslistView32. There's a data model behind where you specify, for instance, for syslist, you specify very tabular style data. You specify the names of columns, the widths of columns, and then the rows with icon and all of the values for all of the columns, so all of the cells. I'm not sure if the built-in Windows controls for list view and tree view have the ability of having everything virtual. So showing, for instance, the list view without having a backing data structure behind it. When the list view wants to display page 6, it just asks for the page 6 and you provide it the data that should be displayed on page 6 of the list view. So this is virtualization. Is very important if you have a huge amount of data to be shown in a list view, icon view, combo box, tree view, and other massive data controls, data grid, etc. So on the registry editor window, we can see 3 atoms. We can see them in here. They're listed. So there's a list view, which is this rectangle. There's a tree view, which is this rectangle. And then there's this location navigator edit box. Let's see that it's an actual atom. We can see because SPI++ can identify it and shows a highlight around the control. And when we press the OK button, it navigates there and says that it's actually a edit box, a native edit box. That's read-write. I have managed to be able to log the Win32 messages. So when I start from the Microsoft Visual Studio Tools main menu SPI++, it asks for validate, for elevate as admin. And then if we search and select messages in the show group box, no message is actually logged. So this type of elevation, there's something wrong with it. It's incomplete. It's not elevate as administrator. I'm not exactly sure what the actual elevation that we do when we click here is. Because if we elevate the process correctly, so it's called spyxx.exe, the name of the file. In the directory c:\program files, Microsoft Visual Studio 18 Community Common 7 Tools. So if you go right click on it and run as administrator, then if we go show messages in the find window, crosshairs, select the entire regedit window. So if we just elevate spyxx.exe, we cannot capture and log the messages, but then if we elevate spyxx amd64.exe, we can. So I'm not sure what's the difference. I'm not sure if this is a 32-bit process and this is a 64. So right click on the correct one, spyxx_amd64 from the Community Common 7 Tools directory, install directory of Visual Studio, run as administrator, yes, find regedit window, back there. So messages in the show group box and then select the window. And now we have all of the correct messages. So there's mouse movement, enter, hover, exit, enter, move, exit. There's a ton of messages of type paint. This is custom painting. And I also tried to capture the main menu, but the main menu is not a atom window, doesn't have an HWND, a handle for the window. Let's capture the events on a very small control, and then let's look at the various types of events. So messages. These two toolbar buttons, Find Window and Find Window Control F, Alt F3, have a very similar functionality. So let's go back where we were previously, which is WinVer. And we want to only capture events that happen on top of this label. Let's refresh. Find tool, this label, because we have in here the hyperlink. And we want messages. Okay, it's showing messages outside the label. Let's see why is that. From the SPY++ main menu, messages, logging options, said include all windows of the same process. I'm going to uncheck this. And save settings as default. Okay. So now if I hover on top of anywhere, any other window than WinVer, about Windows, it doesn't capture any event. If I hover on top of the about Windows, winver.exe, it doesn't show any event, except when I touch the label itself. So remember that the rectangle of the label starts in here and goes until somewhere in here. So it's a bit wider than this text we can see in here. Where is this other button? So it's, I know, 70 pixels wider the rectangle than the text inside the label. Okay, so we have in here, let's see exactly what types of events. Let's see if there's a clear button. So I don't want to stop, I just want to clear the window. Okay. We're entering from above with the mouse. It says NCI test, so it doesn't have a mouse enter event, doesn't have a mouse exit event. Okay, then on top of the A of the anchor, there's a mouse move, there's a cursor position, and then these NCHIT test events. There's way more events on top of the part that's focusable of the label, which is the anchor. So outside the anchor is just NCHIT, NC hit test. Whereas for the A anchor part of the label, There's cursor, mouse move, extra events when I move the mouse. Let's clear again and get to the anchor using the tab key. So we're now focused on the OK, the main button of this window. Press the tab key once and let's look at the events. There's set focus, get focus, custom painting, clean up the background, key up, tab key. And there's ones which probably are not that important to us, which is the IME events, the input method engine. There's IME set context and IME request. And if I click on another window, the about window winver.exe window loses its focus. And now we get events kill focus, paint, erase background. So there's some theming happening there on the anchor, which is probably this pair paint and then erase background, which we can see here 1, 2, 3 when we have removed the focus, and then 1, 2, 3 when we have put the focus inside the anchor part of the label. This also smells like IME, input method engine, MS-IME query position. Or maybe it's the assistive technology accessible to interface, the COM interface. Okay, two words about the accessibility in Windows. Previously, if you had a button, you were guaranteed that that button has an atom window, but nowadays that's not really the case. Again, with web browsers that have just one huge web browser control inside. There's no individual Win32 atoms windows for the various controls inside the web browser content. So for buttons, for hyperlinks, for other forms such as upload buttons, edit boxes, select file, edit boxes, combo boxes, checkboxes, etc. So all of that is a huge Win32 alien control, but then inside there's maybe 1000 hyperlinks. So those hyperlinks inside the web browser don't really have window atoms, but still you need to access those. You need to be able from outside the web browser to automate the web browser. You want to read the content of the web browser. You want to read the content of a cell in a table in a web browser. You want to tell the web browser to navigate to the 7th link anchor on the page, to tell the web browser to search for a certain string, etc., etc. All of these are needed by assistive technologies applications, by screen readers, by applications that help users maybe with disabilities, other automation tasks such as testing web apps. And because there's no individual window atoms there, you cannot actually send a message to press the button or to send the keyboard key X on it. And the alternative is that there's, similarly to the way there's a tree view with all of the atom windows on the desktop on the current graphical user interface session, there's a similar tree of UI accessible objects. So there's two different hierarchies, one of atom windows that you know how to handle. You can inspect with Spy++. You can see the messages that are being sent in there with Spy++. You can send messages with a simple, for instance, I know, C# application that uses system Windows Forms. Whereas the other hierarchy is the UI accessibility hierarchy, where there are objects that are accessible via accessibility technologies in Microsoft Windows. But you can do very similar things with both technologies. You can put focus on a control. You can press Alt. You can press Tab to navigate to the next focusable control. You can read the text of a control. You can set the text of a, sometimes, not always, the text of a control. You can read the text foreground, text background. Maybe you can also set those. You can read the content of icons and graphics and images. You can send various events or see that events have been happening on top of a control. You can tell a control to close itself, to hide itself, to lower its position in the order to be beneath other control or bring it to front. You can, I don't know, change the accelerators of a control by changing its text or caption using the ampersand key on top of the letter that you want to become the new accelerator. You know, you can send key combinations that, for instance, I don't know, you can send a Control C to copy, a Control V to paste, Control A to select, etc. So there's a ton of things that can be done from outside the graphical user interface application, and there's two different technologies that you have at your disposal to access that graphical user interface application, either Windows Atoms or UI assistive technologies in Windows. So this is a deep dive into what you can do using the Spy++ application from Microsoft Visual Studio 2026. Make sure that you're using the correct one, so all of the features are available in the one that has underscore AMD in name. So spyxx underscore AMD64.exe from the tools directory inside Visual Studio. And in here we can see the very low level part of Win32 API, the way it existed probably also in 16 versions of Windows, Windows 1, Windows 2, Windows 3, Windows 3.11, but certainly in 32-bit versions of Windows, such as Win90X, Windows XP, etc. So you can see in there the graphical user interface controls that are not aliens and have attached a window atom. You can see that all of those window atoms live on the first main window thread of the process. You can read a ton of properties of that control. You can set properties. You can see the messages that are being sent to a control. You can send messages to a control. Although the application is running, for instance, you can change at runtime the background of this entire dialog WinVer. You can do it via the Windows message pump and via sending messages. I'm not exactly sure if it's possible to do it via SPY++ application, but you can certainly do it via very, very similar applications. And in here, you get to learn the building blocks of Win32 graphical user interface applications. The fact that there's a WM underscore erase big KG and D. So WM means window message, and then underscore erase background. There's a way to do custom painting with the message WM underscore paint. You can set focus to a random control that's focusable, even if you do this from outside the application that you want. You can set focus to the entire application. With the WM set focus, you can set focus to a control inside the application. And then you can see where control's rectangle is, what are its x, y, width, and height integer values. You can see the accelerators of edit boxes, and not only. You can see the types of controls. You can see static, you can see edit. You can see button. The main menus of Windows don't actually have a Atom window, and then all of the controls that have an Atom window have a very important thing, which is the handle, or HWND, the handle for the window, which is the value that you're using when you want to send message to a Atom window. You need first to have the handle, and then to know what type of message and what are the properties of that message. So if you want to say set the background color of a label, you need to specify that background color via that message, via additional parameters in the message. And that then these window messages that you can see here in SPY++ are the basic blocks for programming when you handle an event, when you send an event, when you trigger an event that affects a graphical user interface control that has attached a window atom. And then if you have programmed in, for instance, Delphi, in Embarcadero Delphi, you can immediately transparently see how that programming language evolved from Turbo Pascal, because you can see how messages, Win32 messages, are being implemented programmatically in a Delphi class. There's an actual keyword for Win32 messages. And then there's enums for all of the message types, etc. And you can even look at the source code. For instance, in Delphi, you have all of the object Pascal source code, all of the Delphi source code of the library, and you can implement Delphi source code to handle an event, go to the implementation of that event in the Delphi VCL library, and then in there you will see HWNDs, window handles, Win32 ones, Win32 type messages, custom painting, etc. all of this is very transparent, and you can see immediately how it's built on top of the native Win32 window atoms, messages, and message types. So this is it. Thank you.